Welcome everyone to this new edition of the virtual DDD. And today we're actually joined by three people. First one is Thomas, or Thomas, or yeah, there's a different pronunciation.
Welcome everyone.
We have Devon on the other side.
Hello.
And we have Vladik next to me.
Hey everybody.
So, Thomas, can you introduce yourself?
Hi, everybody. I'm Thomas. I am in the software industry for almost 13 or 14 years now. I have been working a lot in the insurance industry before. There I learned how software development should not be done. And this forced me basically to look into things, how can we make software development actually work? Now I'm working at Flixbus, which is a long-distance national bus transportation provider, and I am responsible there for the general architecture, working with teams, implementing mobbing and cross-pollination patterns. And I also started on a domain-driven design journey there 4 years ago. Yeah, and I'm happy to talk about aggregates today. It's a very important topic to me. So
Devon, can you introduce yourself?
Sure. My name is Devon, originally from South Africa, but I'm living in the Netherlands. I'm a colleague of Kenny's. I also been in the software industry probably around 15 years or so. And I started my DDD journey probably around 2012, just trying to figure out why things go so wrong and are there ways to make sure it doesn't happen so often. So yeah, I like to say that I've been failing at DDD since 2012. That's how we learn. Looking forward to this discussion. Should be fun.
Cool. Vladik, can you introduce yourself?
Hey, my name is Vladik, and Kenny promised me that I will be in read-only mode, but probably
after this.
Yeah. So my name is Vladik. I'm from Israel, and as long as I can remember myself in the industry, I asked the one single question all the time: how do you implement business logic? And I found the answer in domain-driven design. I am using it since 2010. I used to be a chief architect at a company that used this methodology from the very first day. Worked there for 8.5 years, and recently I started a new journey. And I'm looking for ways to incorporate domain-driven design in this new company.
Cool. So a few weeks back, I think, we were at Kandinsky, KDD now, right, Thomas? And
correct.
We were discussing and you were shouting, can anyone, well, maybe not shouting, but can anyone tell me what an aggregate is? We put your question there online and there were so many different insights, and I think that's the reason why we're here. Can you explain why you have the questions, and can you give a short intro about your perception or your vision about what an aggregate actually is in the DDD sense?
Yeah, so it was not just at Kandinsky. I mean, at Kandinsky, it culminated there, but I was asking various people on meetups, on conferences. I was just asking them, can you explain to me in 2 or 3 short sentences what an aggregate is? And by my surprise, not a single person gave me the exact same definition, right? I mean, words like consistency, words like invariants, words like concurrency, transactions, you know, all these kind of fuzzy words, they were always in there. But I mean, it was always different. The combinations of the terms were different. There was not this single one definition of an aggregate that you know, I heard. And I was pretty intrigued by that. I think us as a community, it's very hard to come up with a well-defined concept of an aggregate, and especially beginners that are just starting coming into the domain-driven design community. They have sometimes hard problems with grasping this concept. And this was the reason why actually we talked on Kandinsky to set this up. And one of my goals for this discussion is to make this definition maybe more crisp, maybe more general, and maybe more accessible to people who just started with implementing domain-driven design. Yeah, and that's why here I have prepared a small presentation to repeat the basics. So if you agree, I would just start showing that, and afterwards we can start on this ground to deepen the discussion. I know Devin already has his question board ready to fire in whenever. There it is. Beautiful. Okay, so let me just share my screen. So I think this one. Can you see my screen?
Yep.
Perfect. So what is a domain-driven design aggregate? That's the question. That is the title also of this meetup. And how has its meaning maybe evolved over time, right? When the term aggregate was coined, a lot of time has passed, a lot of technical advances have been made, and maybe the meaning, the semantics of the term aggregate have changed. And this is also something that we as a community need to discuss. Maybe an aggregate is even more than it was, maybe an aggregate is more now than what it was when it was defined. But I will now touch the basis so we're all on the same ground. So why do we need aggregates in the first place? This is an analysis of an SQL execution plan of a very complex SQL query. And when you read the blue book and what Eric says about it, right? So it is difficult to guarantee the consistency of changes to objects in the model with complex associations, right? And if you look here, the complexity of the associations is immense, right? You change anything at some point there and you cannot be sure that another part just blows up. So invariants need to be maintained that apply to closely related groups of objects, right? Not just discrete objects. So yet cautious locking schemes cause multiple users to interfere pointlessly with each other and make a system unusable. So that's Eric's way of describing the problem that aggregates are trying to solve. And so an aggregate has a few jobs, right? It has to guarantee the internal consistency, guarantee the invariance or business rules. There is a relaxed external consistency, and there's multiple people or multiple use cases or multiple agents accessing or operating on that aggregate. So it needs to manage that concurrent access as well, right? This is derived from the problem description. So Eric's definition of an aggregate, right, is an aggregate is a cluster of associated objects that we treat as a unit for the purpose of data changes. Each aggregate has a root and a boundary, and the boundary defines what is inside the aggregate. The root is a single specific entity contained in the aggregate, right? That's the basic definition of the aggregate that Eric gave us in the blue book. And most of us understand what this means. So boundaries are artificial and roots are real, right? So the aggregate boundaries are artificial and it partitions the larger models into smaller ones to enforce the consistency, concurrency, and invariant guarantees that we have mentioned before. And by making that smaller, you reduce the complexity of dealing with these problems. Aggregate roots, they're actual things like objects, entities, you know, that manage the guarantees for the other parts of the model outside of the boundary, and that other things can hold a reference to, while the internal associations are hidden from the outside world. So invariants are driven by the domain. We're domain-driven designers, right? So here's a little story. Like a client says, we want potential customers to be able to register an account in our system. Okay, so how should that work out? And the customer should only provide his email. And later he could fill out his profile, but it's not necessary at this step. Okay, so we send out a confirmation so we can make sure that, you know, the customer actually has access to his email address. But what happens if, you know, he doesn't confirm his account? Then the developer says, well, at some point, then the confirmation token will expire and he has to request a new one, right? And the client says, okay, let's do it that way. It's a very simple example, but I mean, the important part is to understand that the invariants are always driven by the domain. They're driven by the business. They're driven by the actual problem space of the domain. So basically, we have now a customer registration aggregate with an entity root as an account. We have a status value object, email value object, and we have a token entity there as well. And the outer world only accesses the aggregate through the root, right? Within the aggregate boundary, entities and value objects are allowed to have references to each other, but they're only unique within the boundary, right? It's not necessarily that they are unique across aggregate boundaries. All invariants are guarded by the root. For example, confirming an account only when the token is not expired, or other use cases. And we need to make sure that references from the outer world never cross the aggregate boundary and have references to the inner workings of an aggregate, right? For example, here, the token entity. And all changes within the aggregate boundary, they need to be consistent. For example, having all the changes persisted in an all or nothing ACID transaction. I mean, there's multiple ways of how you can ensure consistency. This is just one example of how you could achieve that. The important part, that it is consistent within a transactional space. So now this is very successful, and the stuff is scaling and growing, and we're successful, and suddenly we have to shard our database because a single database instance is not, you know, able to handle this amount of growth. And some people came to the idea to shard it that way, right? So we have the account entity in database shard A, and we have the token entity in database shard B. And now the aggregate can only be reconstituted by querying all shards, right? Which is not a really good thing. And same with microservices, right? So yeah, we have the account microservice and we have the token microservice. And we have exactly the same problem. Instead of querying all the database shards, now we have HTTP or REST call or whatever, GraphQL, through the network, and we have the same problem, right? So what we need to do is, or need to realize, is that an aggregate is also a unit of distribution, right? So if you need to shard it, if you need to distribute it, you should shard distribute the whole aggregate in itself. Another thing that is important to know is like, okay, so we have this user registration context. So whenever a customer has opened an account, an entry in our CRM module should be created, right? So we have this other aggregate in the CRM context. So how do we make the following consistent, right? How do we manage these interactions between aggregates? And Eric, again, on rules across aggregates. any rule that spans aggregates will not be expected to be up to date at all times. Through event processing, batch processing, or other update mechanisms, other dependencies can be resolved within some specified time. So what that means, communication between aggregates is actually eventually consistent, right? I mean, depends on how much eventuality you want to say. In some batch processing, it might be days. In some real-time processing, it might be minutes. But I mean, it's not going to be immediately consistent. Then there's something else. We have the static models right now, but most of these static models, they're missing something. And what they're missing is a notion of time most of the time. They're missing a notion of time most of the time. And I think it's a very important feature. And the question is, so why are techniques like event storming, domain storytelling, or story mapping, why are they so successful? And I believe there is a very specific reasons for that. Because if we look in systems theory, then we realize that actually complex organizations, complex systems, they are working in the patterns of events. The behavior of a system is shown in the pattern of the events. So this is actually a quote from Katz and Kahn, social psychologists from 1978, and it's still true today. So these techniques are so popular, not only because they enable temporal models, so adding a fourth dimension of time, but they're much closer to the actual behavior of complex systems, right? And not only because they create a compatible mental model between all the participants, it's fun, it's nice, but also because they give really a glimpse of how these complex systems actually work, that static models are just not able to deliver, right? The knowledge encoded in these static models is lost. You can project an event-driven model always to a static model. You can never project a static model back to the events that generated it. Yeah, and I think that was my summary of aggregates. And I hope you have some questions, you have some comments, you have some feedback, you have some ideas, and I would love to hear about them.
Thank you for that. I think, Devon, you can kick it off with some of your boards, right? Questions?
Sorry, was just unmuting. I have lots of cars driving past here. Yeah, I'm wondering if I should start from the beginning or just the last thing that you mentioned there, and maybe let's start there because it's quite interesting with the temporal modeling. You mentioned the temporal modeling, but how does that then relate to aggregates? What do you find yourself doing that's maybe different to what was sort of discussed in the Blue Book to model time?
So what I find myself doing recently is I'm actually so I studied computational linguistics. So I wasn't a pure computer science student. And I managed, or I worked on a lot of problems that were process oriented temporal. They were, coming from the natural language processing area, but they were very related. They were very temporal. They were very process oriented, and they were very stateful, right? So there I found something where I said, okay, aggregates are actually, something like state machines. They're something like processes. They depict something in the system that has a start and an end, and there's stuff in between that is happening and that has a temporal dependency to each other. So what I found myself doing is actually using the mathematical models of finite state machines to actually model the aggregates. And it was a very natural fit with the event-driven, with the temporal process-oriented approach of aggregates. And I sincerely believe that an aggregate, that we should actually go completely away from the static modeling, because it's not close to the reality of complex systems. A static model cannot capture it. As much as you try it, it's impossible to capture it. So
audience, just to jump in, what do you mean exactly by static model versus temporal model, just for the people who don't know?
So a static model is always depicts one point in time at any time, right? You only have a current state of things, right? Let's say you added some order items to an order and you run the database transaction. And now you have the order with 3 order items. And whenever you query, you only have that specific point in time, that specific state. You're not able to understand, okay, what has happened before, or you cannot derive it anymore. And when I say it's a temporal model, then I am going to be able to actually say, okay, I know what happened before adding this order item, or I know what happened before it was removed from the order, or I know what kind of checkout things happened before. So I understand the temporal and logical relationships on all the system events that, built up to that transaction. So I hope that was clear enough.
Yeah, I think it might be useful to maybe sharpen that up for those listening a bit, because just off the top of my head and from experience, I can imagine 2 ways of maybe actually, if you were implementing that, what that might look like. So something I've done in the past is, you have your normal like static model, but then as you interact with it, you store events on it that could have happened, or you return those events and collect them as you go. Is that sort of what you were talking about with moving to a more temporal model?
Well, that's one way. So basically that's capturing the history of things, right? You have a static model, and this static model is capturing the history of what it does. But the model, it's still like, there's the static thing, there's this temporal thing, and you want to put them together, but you can't, because the static model needs to, do something else, publish that somewhere, need to analyze it separately, you need to have some other infrastructure to deal with that.
Yeah.
So it's, you can't put them together, but they're not really matching, right? Yeah. It's, when a small kid tries to put the triangle through the circle hole, and
I'm sure I could find something like that here right now.
So it's a little bit like that. I mean, you can make it work, but still the models are not compatible, right? It's not reflected within the static model. You're bolting it on top.
Yeah. So I apologize to you, to listeners, because I've tried to restrain myself from bringing functional programming in as long as I can. Because something you mentioned earlier with, say, the token expiring, another way that I've seen to model that is, instead of thinking of, having a single static model, you have your before the tokens expired and the after your tokens expired, and they're 2 separate still static models, but you move between the 2. And I guess that's coming closer to what you meant as a state machine. Yeah.
Yes. So maybe let me share the screen for a moment, because that might make things a little bit more clearer. Okay. So from a static to a process model, right? So we had a static model. I was describing it. We have this token. This token probably has a status where you have expired or you have an expiry date or whatever, and you know, you query it. But you can transform it, right, to a model like that, where you say a potential customer, he wants to register himself, so he's awaiting the confirmation. And you know, either the confirmation is the account is confirmed, or the confirmation expired, you're an unconfirmed account, and then the confirmation is sent, right? So this is a more process-oriented model of the things. And when I talk about the finite state machines, I call them finite state transducers because there's a slight difference between finite state machines and finite state transducers. So finite state machines, they don't have an output, right? They only have an input band. So you can only send commands. You can only send commands to it, but you will never receive anything from that. So an example of that, yes, here, is like a turnstile, right? So the only output you will receive from that is the feeling when you try to go through, but you haven't put a coin in it, and you suddenly feel the pain in the hip because, you know, it was not open. But it doesn't have an output per se, it just has the state. This is normally not really useful in software environments. Normally you want to have output, you want to have, you know, something that the system can react to. And I came up with something like a mathematical model. This looks like very crazy right now. This is a sextuple, which defines a transducer. It has the input alphabet I, the state alphabet S, the output alphabet O, the initial state S0, a relation of state and input to another state, and a relation of state and output to another output. Actually, it's wrong. It should be actually state and input to another output, right? And if you now, so this looks very, very functional, but you can translate it into domain-driven design terms, right? So you have the input alphabet is basically the commands that this aggregate can receive. You have the states that this aggregate can have. You have the events that this aggregate can produce. You have the initial state of this aggregate. And you have a state command relation to a new state, and you have a state command relation to an event. So maybe that made it a little bit more clear about where I was going with my ideas. And I think this is like very advanced. It's very early stages in my head of where I want to go with this. But again, I think that we need to move more towards process system event-based models to really depict the complexity of the systems that we're dealing with. And with domain-driven design, we embrace this complexity and we want to get hold of this complexity. But I think the more I learn about these complex systems and the social interactions, not only from a software perspective, but also from a socio-technical perspective, right? When you add the people who are involved in software design, when you add the people who are actually using the software, then it gets even worse. The complexity explodes. So I sincerely believe that we need to evolve aggregates to get away from these static models and move towards process temporal oriented models.
Well, then, I mean, do you think, is it even worth now talking about sort of the classical static aggregates? Or Kenny, I don't know what you think as well in terms of just should we keep down this, or should we, because I don't know whether this is a introduction or where are aggregates going?
Yeah, so maybe we can return to that later, because I got a question from someone, and it resolves more about the design of aggregate, right? So away from, so this question goes a bit away from this discussion static versus temporal, but it's more like the question is, are there any cases when we actually need to have immediate consistency across aggregates? The short answer, of course, I would say is no, because that's out of the rules of the aggregate. But there's problems I sometimes myself face when I model. Is the example here is using an account aggregate. What if there's another aggregate that holds the reference to the account aggregate and publishes an event that is supposed to perform some actions, make purchases for instance? How can we prevent the situation of having an account having multiple such references? Do you understand where the question is going?
Devin, do you want to?
No, I'm still trying to understand the question. So,
yeah, so sometimes two aggregates relate to each other in a way.
Yeah.
Where I'm thinking of a past example here, where you have a conference you want to, let's say you have a list of conferences you want to submit to, right? And there's a list, okay, these are the conferences we're submitting to, and you're putting that in an aggregate, let's say that. And then you have another one where people have an aggregate of what did you submit before. And these two relate in the sense that if you delete one, then you cannot, and the other one is eventually consistently, and you submit in the other one, but it's already gone in the first. Do you know what I'm going at?
Yeah, I had a question sort of relating to this, where in those situations, the initial impulse might be to okay, well, maybe I have something, above this that holds my collection, which would be simple if, data wasn't a problem. But often what that means is you're pulling in just a stack of data into your aggregate, and sort of maybe touches on what I wanted to bring to you guys in terms of what happens when you have a sort of some consistency boundary that you're trying to model, but that consistency boundary is just a load of data that would be pulled in, and it's just not feasible to actually make that aggregate what from a business perspective is. And I think that's where we just have to fall back to, like, eventually consistent, which I think is what the what was his name? Oh, I'm scared to try pronounce that.
Yeah, I hope I pronounced it correctly. Yeah, so I think the deal is also with these. Let's give a real example. I will fire Vladik in my company, right? And he has a lot of access in a lot of systems, but the moment I fired him, I don't want him to have access to all the systems. But it's not consistent in a way that if I press a button, he won't have any access to any system anymore.
Yeah.
These are all eventual consistent, and you come to these situations a lot.
Yeah.
People I struggle with it myself from time to time. So where do you draw the boundaries of when do you want to, like Von Vernon says in his 4 rules that you explain very well, Thomas. And one of the rules, design them small and then protect business invariants, right? That's the way you want to go with modeling aggregates. But sometimes, where is that limit of when can I use still eventual consistency and when not?
So I have also an opinion on that. I mean, in the end, I mean, and Vladik says that we're there like business logic, so business, right? So I think the one place where I would go is the domain experts and the people who want that system to be designed, to ask them, hey, so if we want to make that consistent, there's going to be a lot of data, and it's going to be very, very hard to manage that in a consistent and transactional way. So if we have eventual consistency in just between aggregates, sometimes I find myself actually using sagas in order to manage that. So that, you have this eventual consistent business processes, but you put a saga in between that can, mitigate between different contexts and different aggregates in order to make sure that these kind of deletions are happening. And what it could also do is, I like your example of, security related issues that, you deleted account and you want to have, I don't know, your Azure account and your GitHub account, you want to be removed from the organization, whatever there is. And the Saga can then notify, right? If something goes wrong with one of the deletions or with one of the processes, the Saga can then notify someone in the organization, maybe a security officer or some other responsible or accountable person, that then at least knows, that something went wrong and can then manually interfere. I think Greg Young said that a few years ago, that we don't have to resolve 100% of everything that can go wrong. If we can have 85 or 90% catch that amount of things that can go wrong, and it's not very expensive to deal manually with the other 10%, then it should be totally fine, right? We don't have to resolve everything, every edge case 100% with software all the time.
Yeah, as soon as the security thing came up, the question that popped into my mind is ask, the business guys, the domain experts, how would you handle this if you were actually just doing it manually? And that will often give you the answer of what to do in your code and if you can't resolve it.
Vladek, you wanted to?
Yeah, so I wanted to follow this security topic, and I think we can actually grab a page from the OAuth protocol here, because we have this token which provides you access to some resource, but this token is only valid for a limited period of time, let's say a minute or 5 minutes. And then you have to refresh it against a strongly consistent entity, let's say an aggregate in our case. So if you would implement it that way, we would still have this window of eventual consistency, but it will be limited by definition to some period of time, for example.
That's an interesting way to model it.
If all the systems would speak the OAuth protocol, yes. But the reality in complex systems normally looks a little bit different. So there is a multitude of systems that are interconnected, where user accounts are being provisioned and deprovisioned. And, we're using OAuth, but even in our organization, which is now 6 years old, there is a multitude of authentication and authorization protocols and user accounts. So yeah, I totally agree. If you limit the lifetime of the tokens, you get this thing of security. But a lot of systems there is not this one single protocol where all the authentication authorization will go over to that. If it was like that in our case, it would be very simple. But again, the reality bites very strongly.
No. Physics.
Okay, cool. John asked in this question of 1M related aggregates, this is just as important, I think, as the state and life of the aggregate. It seems on the surface that if you need to validate the true current state of a related aggregate before a method is run, can it check through the aggregate root that the condition are acceptable if it is mission critical to do so? Question mark.
Can you repeat it? Can you repeat the question, please?
Yeah, so it's, I think it relates to if you need to validate the true current state of a related aggregate before something is run. So this is what happens sometimes too, when I see people model, right? A command comes in and you need to check if that command can be run by checking to another aggregate. For instance, I see people do this before you can actually so if the conditions are acceptable to actually run the command against the aggregate. Sometimes I see people do this.
I mean, the problem there really is that when you're checking it, it's already stale. So there's, this maybe gets to, we maybe need to talk about how you handle sort of concurrency in your aggregate, because there's always the chance that it's stale. So that needs to be handled. And if you're persisting, if you look at another aggregate, make a change to an aggregate and say you've got versioning on it or something, and then you try to persist it, and it saves and it's stored in the database, but when you are checking that other aggregate has changed, you wouldn't know that. So it's, for me, that's a really difficult one, because you actually can't be sure.
Yeah, so the thing I also wonder, and maybe John can relate it a bit more. So there's two things: either you check with the other aggregate, or you keep the state, so the current state, in the aggregate root, so that it can check the condition as acceptable. That feels like if you're putting too much in the aggregate root itself, but I'm not sure exactly what he means by that question. So if you can relate a bit more or explain a bit more, that would be awesome. Okay, so now on the thing you mentioned earlier, Devon, you're a fan of functional programming. Thomas, you explained really well the aggregate root the way Eric Evans explains it 15 years ago, where most of the people were in object-oriented, right? And talks about objects and talks, and we explained it with Scott, but how would you see root entities and, aggregate root and aggregates being implemented in functional programming? Does the pattern still exist? Because it's saying, well, there's an entity.
Well, for me, I think what would change is that, your type of the data is being enforced in a different place. So, I would typically if I'm doing functional programming with DDD, most of this is sort of out of Scott's book, but where you have a state, it gets transformed into another state, gets transformed into another state. And in that transformation is where you're checking sort of any invariants. And what comes out of that is a bunch of maybe some state and some events that occurred during that process. It feels like quite a stretch for me to really map this to classical static aggregates as we have them. The correlations could be made there, but it's a bit of a stretch. What really does jump out to me there with those is that what really appealed to me about aggregates when I learned about them is it goes along with that whole make illegal states unrepresentable. And that's what I'm trying to do in an aggregate. It's why I was drawn to functional programming as well. I felt like I had more tools for doing that and enforcing, and specifically with sort of ML-based languages, the typing really helped me sort of make those illegal states unrepresentable. So I think that's the main point that jumps out at me in terms of where an aggregate sits in that. But the classical thing of, something with data and it's got behavior on it and it's enforcing the business rules, I don't really see it there.
I have a question to that, actually. So I like a lot. I like functional programming a lot. I was working a lot with object-oriented languages. I was switching over the last 1 or 2 years towards functional programming because of the reasons you were mentioning, that making illegal states unrepresentable, splitting data from behavior, all of these kind of things that are very difficult to achieve in object-oriented languages. So maybe the aggregate root could be something, if you give something back to clients. So you have this super type, that you derive the states from. Maybe we could say that, the aggregate root in a functional way would be basically the super type of, you know, the queries or whatever that you would give back to the clients. Maybe that there is an analogy that could be made. I'm unsure about that. It's just an idea. What do you think about this?
Yeah, in saying that, just thinking about how I'd actually implement this. So, you know, you mentioned this sort of state machine or state transducers earlier. Typically, that's what I would have a super type or that moves between these different types, and that kind of, those are the only states that it can be in, and it moves through those states. So yeah, that rings true to me, that you would have sort of some type that represents the states that you can process through here. So that's definitely a very strong analogy, at least to the way that you eventually got to aggregates as more of a temporal model. So yeah, I changed my mind. That there is definitely something there in terms of, if you're looking at it as a temporal model, or your aggregate being representative of time, then there is definitely something there in functional programming.
Yeah, so that's the functional way, right? And only a lot of people coming into DDD nowadays are mostly object-oriented people, I think.
Yeah.
Would you say that if they want to move, that a functional programming language is more natural to well, not even to DDD, but to model business, to implement business models, let's say it like that? What would you say, Thomas?
I mean, I definitely think so. It's something that's been bouncing around in my head for a good couple of years now, is that I actually suspect that, you know, a junior coming in and learning functional programming would possibly, you know, get to the point where he or she isn't like painting themselves into corners often, like you tend to do in OO. You know, in OO, there's so many principles and techniques and all these things that you need to learn just so you don't, like, you know, paint yourself into some kind of design corner and have to struggle to get out of it. I find functional programming, funny to say, like a lot simpler in that, you know, there's some complexity there, and especially the language around it can make it a bit confusing, but there's less constructs that you need to learn to just start being productive in it. And then when it comes to the modeling side, I feel it has better constructs for doing that modeling. And again, if you're doing a very sort of statically typed language, you get a lot of safety there in terms of, you know, enforcing your invariants and making illegal states unrepresentable.
I totally agree. Also, I believe that there is a place for object-oriented programming, and there is a place for functional programming. So I don't say that one is better than the other. I just think that functional languages are better at process-oriented temporal models. They are better at depicting that. And when we deal with complex systems and deal with these events that are inherent as the patterns within the systems that we try to derive with things like event storming or domain storytelling or story mapping and all these kind of collaborative knowledge crunching tools, but the models that we can derive, they're one-to-one representable in functional models. Or even I think Eric Evans actually mentioned Prolog as a perfectly suited language to implement domain-driven design and business constraints. So even Eric already knew that, you know, it was actually very, they're both declarative ways to handle that. And he actually mentions in the Blue Book that, you know, that Prolog is actually a perfect match to map these patterns into code.
Yeah, I agree that there's there's pros and cons on both sides. Something I keep finding myself with OO code is so much more discoverable generally than functional programming or functional languages as well, and that has a real benefit when you've designed a model and now another developer is using it. Discoverability like really sort of helps keep things consistent, helps people find things. So definitely think both tools in the toolbox are valuable.
So we're almost a bit running to the end. A few questions I still have is, the first one is, we started talking about what is an aggregate. Do we just got more questions out of this discussion like usually happens, or are we more, for me it's clearly defined the way you started it, but how do you feel, Thomas? How do you feel
as I stated before, I think, and I hope that the future will prove me right, that, and Devin said it as well, is I don't believe that, with our growing understanding of complex systems and our growing understanding of how complex systems behave and how we can map these behaviors, into software that does useful things. I believe that, we need to go away from this static, which is, it's very common in OO scenarios, to be honest, because there's all this infrastructure already there, the frameworks, all this kind of stuff that, is based on this, I will not say outdated, but, the original description of it. I think we need to elevate aggregates into, accepting that it is a process-based and temporal and event-driven representation of the actual system it depicts. So this is something I hope I could make clear to the people that are listening, that, I think there is an evolution of, what we understood as an aggregate and what an aggregate will be in the future.
Yeah. So
can I just float an idea on that maybe there's a spectrum here rather than a, this is wrong or this is outdated, which I don't think anyone's really saying, but, Thomas has pretty much said this throughout, that we're moving to more and more complex systems. And just like I think, there's some solutions that are being built, I suggest to people, just don't even worry about DDD, like especially the tactical patterns, maybe start introducing some, learn what your ubiquitous language is, but don't get too hung up on the DDD part of it for this, because this is such a simple problem or solution that you're building. It's supportive. It's not even your core domain. Just, build your CRUD system and get it done. And concentrate your efforts on your core domain. Maybe there's a scale here where a certain level of complexity, just the static model is absolutely fine, and that's going to serve you really well. But I think as you get into more and more complex scenarios, you're going to start hitting the limits of that too, and it's going to start becoming unwieldy. And there's I think something fundamental here is that you're breaking down a static model into now bits that go through time. And that at the end of the day is what DDD is about decomposing something that's complex into smaller manageable parts. And now we're just flipping things around a bit and doing that through time. And I really like that idea of having, a bigger, broader toolbox.
Yeah. And I think Rebecca would love that conversation, right?
Yeah.
So changing heuristics or changing patterns if you listen to all her material. Sometimes we need to update some patterns and not. And that's why I want to go and move towards the last question. And Christina jumped in here too. Is why? So why in aggregate? There's discussions, and new people coming in don't know what an aggregate is. Let's say that, right? I didn't know from the start what this actually is. So for some reason, it's not explicit enough. And I've heard Rebecca say this, patterns are usually written for experts to discuss with each other. And that might sound elitist, which I'm not saying that, but it's like looking at Aikido in the Shuhari kind of way, right? If you black belters do this, so the higher dans do this stuff that I don't know how to do, and I need to start lower. So shouldn't we focus on the learning part of how to learn how to what aggregates is instead of explaining it as a pattern so that other people can move more into that? So is it really important to the explicitness of an aggregate, or should we be explicit but give away certain shuhari, like first just do this and you will be fine for now, just start in less complexity, and if you go to complexity, so explain complexity, then bring in someone who's a Dan who done it before and can guide you into that. How do you look? I know we had this discussion a bit, Thomas, at Kandinsky. How so as a final question, how would you?
So, I mean, when we talked about, or when I was presenting the aggregates, I mean, there was a problem statement, right? And the aggregate was a solution to a lot of problems that this interconnected model presented to the people. But I think we can, split these properties and look at these properties one by one. So, for example, a unit of distribution is like, okay, you want this closely related concepts not to be distributed across the network, but you want these closely related concepts to be, very close together in the same memory space, maybe. And maybe we can just then go, okay, so now you want to have concurrent access. So right now, so it's a unit of concurrency. So maybe we can, have these different levels of the different properties that solve different problems that originate there, and basically build on it, like the dance you were saying, like you get the concurrency Dan, and then you get the distribution Dan, and then you get the invariance enforcer Dan, and then you step up the ladder, and at some point you have the aggregate Dan, right? And then you are free to discuss with Rebecca.
Okay, cool. So to wrap up, what is question to both of you, and let's start with you, Thomas. Tomorrow people will go to their work. What's the first thing? What's something you want to give to people listening towards this concerning what's an aggregate? What's the first tip they can start doing tomorrow?
That's a good question. The first thing you want to do tomorrow. So I would say do the invariance enforcer Dan, because I think that is the most important property of an aggregate. So basically ask your domain experts or people, okay, what are actually the business rules? What are the things that we need to enforce? And then build something where you center all these related business rules into one object, one function, whatever it is, just put them together and have them being resolved in this central piece of code. Because I know in my experience, I made this mistake a lot of times where I allowed access not only through the root, but also through the internals, and then enforcement of invariants spread across the whole system into various services, and that was a real pain. So that may be the first thing when you come into work tomorrow. Look at that and maybe try a small refactoring, centralizing these business rules that are closely related together.
Cool, thanks. Devin?
Yeah, I think I'll go a little bit smaller, aiming this at someone who maybe doesn't know really any DDD or, just started looking into it. I'd say concentrate on that, making illegal states unrepresentable. So, there's lots of new terms and whatnot in DDD. It's good to start learning them, figuring out what they mean, but start with making illegal states unrepresentable, and adding to that, and part of that actually is starting with value types, value objects. We can paste, I've got a little blog series on them, and I don't even call them value objects, just to not trigger any DDD anti-cargo cultists, because they really have value in describing your domain. And I think it's something, entities comes really easy to people, but value objects is something that people struggle a little bit more with sometimes. So I'd say, make illegal states unrepresentable and try introducing value objects, and aggregates will start coming together then, I think, if you focus on those two things.
Cool, thanks. We'll definitely link it in YouTube.
Cool.
Anything to add, or still in the listening mode, which is fine.
I'm not in the listening mode for a long time. So I would say my suggestion would be to examine the requirements of the business domain and expectations. So even if you don't have proper aggregates per se, just examine what kind of consistency expectations do you have in your business domain, between your entities, between your services, etc. And it will give you a clue. Maybe there is a place where the business domain needs some strong consistency, but you only provide eventual consistency. Or on the other hand, eventual consistency is enough for the business, but you enforce strong consistency. And that can give you some clues where the system can be improved.
Great. Well, thank you. Well, that was it for today. Thank you, Thomas, for starting this up. Thank you, Devin.
Pleasure.
Vladek, for joining here.
Thanks. Pleasure. Thanks for the invite, Kenny.
Good. And any feedback, please let us know. You can go to the site virtualddd.com. You can also submit your own talks or discussions, or any format that you like, you can submit. Next Tuesday, we'll have our first one, make the test speak the story of your domain. So please join then again. And until next time, thank you very much.
See ya.